So now I'm going to show you about cams. So cams will come in three forms. We're going to have our uniform velocity, our simple harmonic, and our uniform acceleration and deceleration. So how you find these are in three different ways, and the cam profiles they produce from the displacement diagram are also different. So this is the cam, this is the displacement diagram, and you can see the three different types of cams they can produce. So the setup of this question is pretty much the standard. You will split this up into 12 and also a cam up into 12. So each of these stand for 0, 30, 60, 80, or 60, 90, 120, 150, 180, 210, 240, 270, 300, 330 and 360, and they correspond to here. So as you can see, it starts at the top, it'll end back at the starts at the bottom, it'll end back at the bottom, so they join up again at the end. So for uniform velocity, this one is here, it's pretty simple. You just have to join the lines as it is. You can have uniform velocity like that as well. So it doesn't have to be constant to the center, but it's not the most difficult to draw. You just have to know what it would ask in the question. So just say if it asked to uniform velocity to 120, you go 0, 60, 0, 30, 60, 90, 120. This would be uniform velocity all the way to 120 and then back down to 360. You then bring over your points here all the way across, and then you draw increasing size circles where they join up and where these cross the resulting 90-degree line or 120-degree line. You can see that this is where off, so I'll track one point here. So this would be the 60-degree line. So we bring it all the way across, and then we'll be bringing it down, and as you can see, 0, 30, 60, that's where it crosses. So it's the same. As this is the same both ways, it also does the 271. Similarly, for simple harmonic motion, the curve we produce is different. We do this by drawing a circle at the end and lining them up, lining up the points across. So this is the 30-degree line for the circle, so you see 30 degrees will be the second one, and then it moves across again. So you can have simple harmonic as well for smaller parts. So we could have, just say, we could have it being uniform velocity to there, and then we'd have to find the simple harmonic then for the rest of it here and find it as it tracks up and back down. Similarly again, we bring all of our points across and they will line up down here. So we shall track the 91 this time. It will come across, draw a circle, where it lines up is the 90-degree line, so here. Once you have the displacement diagram drawn, it's very simple. It's very similar all throughout how to find the cam profile. The last cam profile that we will be dealing with is, uniform velocity or uniform acceleration and deceleration. So for this one, we can see that we will find the center line, and we will track equal distances up and draw it back to the corresponding line. So you see these orange lines where they cross each line here will be the endpoints. So where each of them cross is the lines here. So again, we could have uniform velocity, then simple harmonic, and then end out with 1/2 only being uniform acceleration and deceleration. So these are found by splitting this line into 6, joining the first 3 back to the start point and the middle 3 back to the middle point. You could do this over 2 as well, so it'd be only up to 4. You'd still have the same distances, and you would draw a line back. So instead of that being the first line, it would be here. Since we're only doing 4 now, it'd also be bigger. It'd be twice as large. This line here, so it might be something around that size. And then where this crosses the line would be the point on the curve. So we can get rid of these now. Then again, it'll be the same here. You'll be producing a cam, bringing the lines across, and then finding its resultant down here. The only other thing we would have to worry about would be the types of followers there would be. So we would have a knife edge, which would look something like this. We would have roller followers, flat edge followers. So a roller would look like that, and then a flat edge follower would be something like that. So there would be the 3 main types. So the only difference is that we would have to take into account the radius as it moved around, as this one here can focus on certain points. It'd be more accurate. If there was a large jump, these ones here mightn't be able to work as well. So there are the 3 main types of cams and the 3 main types of followers, and they remains constant throughout after you have the displacement diagram drawn. So just to recap, you have the cam here, displacement diagram, and how to construct it. Thank you for listening. Goodbye.